Hi everyone, welcome to Math Spellbook. I'm your host Peter, and basically we are going to get into it today. How are you, Mean Machine Rex? like the emote. It's like I wonder, like is that from another Discord server, or did you just make that emote yourself? It's actually a really cute emote. I actually like it. Anyway, so hopefully you guys can hear me. Let's see, my mic looks like it's working fine, and it's attached to OBS. That is good. So let's get into it. Let me get my trusty tablet pen. Oh, I have to actually click on my tablet screen, so that way we can get that working. Okay, so last week we went over vectors, so I'm just gonna look over my notes really quick. Yeah, it looks like there's like a lot of, it's one of the default emotes, I think. Oh, okay, okay. I never seen that emote, actually. But how are you doing, Mean Machine Rex? Is it okay if I just call you Rex? If that's alright. So, let's see. Yeah, there's a lot of coordinate systems here. I just want to look over them one more time because the thing of it is that you're doing great. Oh, what was the best part of your day so far? Okay, cool. Yeah, I'm glad you're doing great, Rex. Oh. Oh, thank you for the follow, Rex. Thank you, thank you. Hello, Penn Center. I will actually give you a shout out, actually, Penn Center. So, if you guys don't know, Penn Center is also an awesome math streamer. So let's see. I'm trying to do the Twitch shout out, so just give me a quick second here. Yeah, so if you guys want to get better at math, Penn Center's like streams are straight up awesome. He is teaching a course on linear algebra as well as real analysis. I always come in during his real analysis live streams. So if you really want to learn from like one of the I had the words in my head. If you really want to learn from someone who is experienced in math, please check out Penn Center's streams, please. And I'll probably be sitting in the lessons with you. So, you know, be sure to check that out. I had read in front of people. I got very nervous and heated. Oh, let me see here. Let's see. I had to read in front of people and nervous and heated. Oh. Was that the best part of your day? Oh, hello, e to the 2 pi, 2 I pi. Yeah, reading in front of the class is usually like, really like intimidating. Like, is it okay if I call you E2? Because I know I know your name is basically an awesome like series of constants, but I just want to shorten it to make it easier. I did see your lecture on like different maths. So like I think like you were talking about like some infinite series as well as doing some proofs last stream, but you weren't feeling that well, so you just like made it short. But that was fun. Yeah, no problem, no problem. You know, like reading in front of the class is not easy. I remember I had to do an assignment for like Italian class. I wrote an entire story in Italian and I basically read it to the whole class and I was super nervous. I don't think anyone understood what I was saying at that point. Okay. Getting over the illness, I think. Okay, that's fine. Recover at your own pace. Recover at your own pace. People say get well soon. Get well get well soon. But I say get well at your own pace. Recover at your own pace. Okay, so enough of me yammering. I've wasted time. I mean, like, I like greeting you guys, but at the same time, I know you guys came in for the math, so let's just get started with it. So, study timer. There we go. So, today we're going to go over vectors, and I'm just looking over my notes because I don't want to keep looking at my notes whenever I have to look up coordinates, because we have to do so. I gotta use my actual mouse here. Because we gotta remember spherical coordinates, cylindrical coordinates, and polar coordinates. Polar coordinates, I feel like I'm already, like, I've seen it so many times that I can remember it. The only thing I can't remember is the unit vectors. So I have to find a way to, in my head, to remember, and I think I found a way. Cylindrical coordinates, that's about almost the same. Yeah, that's about practically the same, so... yeah, even the unit vectors are the same. Spherical coordinates, I think I'm going to have the most difficulty with. R, I think, is going to be easy to remember, but I have to remember that theta is this. Oh, and I think I forgot to put the parameters of what theta and phi should be. Hopefully I'm pronouncing that right, because I think it's phi or phi, I don't remember. Alright, so I have to write the parameters, so theta and phi. Now I gotta look this up. Luckily I still have some of the old stuff that one of you guys sent me. I want to be able to know these without having to look them up, though. Because I know, like, to better remember them, you have to do it by derivation. But I haven't developed that technique of mine yet. So 0... Oops. That infinity doesn't look right. And you guys are free to type into the chat. I will get to it when I look over, because more likely I'll look over what you guys are saying in the chat. So don't feel like you're interrupting me or disturbing my train of thought, because sometimes I like to look over chat just to basically get my mind off of the problem, so that I can actually like have that momentary moment of, like, I guess, brain break. So that way I can just basically like, okay, I'm not thinking at it at the right angle. Okay. The unit vectors for spherical coordinates look scary as heck. I don't even know if I can remember those. I think we'll get to it when we get to it. If I have to look at my notes, I'm gonna be like a normal student and be like, okay, I looked at my notes, it pains me to do it so, but that's what happens. We'll shift that to the side here. Okay, so let's look at the first problem that's in this book. So the book I'm looking through, guys, is Student's Guide to Vectors and Tensors. Student's Guide to Vectors and Tensors by Daniel Fletch. I believe that's how you pronounce his last name. So we're gonna actually do problems from this book. And I kind of like this book, actually, because it kind of broke down vectors for me. And well, I already knew about vectors, but like things like curl and divergence and stuff, I think the way he explains it was like something that I needed to read, and it felt like it was like much better for me to comprehend. Okay, let's see, first problem. So, okay, and I apologize if my handwriting doesn't look too great, guys. I will do my best to write as legibly as I can. Point B. Oh, what the? Oh no. What the heck happened? I must have pressed something. Come on, whiteboard. Come back. Small technical difficulties, guys. Use Meadle. What is Meadle? Yeah, if you guys actually know like any good note-taking apps that like I can put on Windows, like please let me know, because I don't have an iPad. Like, I think the best like note-taking app I think is on the like the iPad, and oh, I don't have that. Okay, here we go. Let's drag this over here. I did try OneNote, but I didn't like the way OneNote functioned for me. It did look cool, but at the same time, I didn't like the way it functioned. Free online whiteboard. Oh, okay. Like I'm guessing it's on the browser, right? Okay. If the magnitude of vector B is 18 meters, and vector b along oops. I have to learn not to rush myself when I'm writing these questions. I always write the questions down because sometimes I end up doing something different and I accidentally solve the wrong thing. And then I look at the directions, it's like, that's not how the problem's supposed to go. And I'm like, oh, crud. Don't you hate it when that happens? You do all that work, but you realize you were doing the thing that the question wasn't asking. Let me just type that in so I don't forget. Needle. Innovation white space. Okay, I'll just leave that on Google for now. But thank you for telling me about that, Rex. I really appreciate it. Actually, on my other Twitch channel, there's like another person I met there who's I also call Rex. I just find it funny that you two share the same name. Like the same online name anyway. So, C of Y is 5. So this is the velocity vector. Find the magnitude. Actually, if Penn Center's still in the chat, like I wanted to ask you if I can actually do the problems you posted for the real analysis course on my stream, if I feel like I want to work on those problems during stream, because I think they're very great problems actually. Sometimes I work them off stream, but at the same time it's like, you know, I think it would be fun to actually do those problems like on stream for me, just to practice real analysis. Because I think for me, it's like with real analysis, I don't have really real direction. But because you're actually setting up a course, you set up the course for real analysis and you provided problems for us to solve. I feel as if, okay, this is the step for me to actually take to initiate a problem set where I can actually feel like I'm actually getting a grasp of real analysis. Let's see, the angle. I hate it when I lose my place. That makes, okay, that makes with the positive, jeez, the positive x-axis. We were a batch of genetically engineered clones. Feels amazing. I don't know where that came from, but okay. We'll go with that. Okay, now let's okay, so B, the magnitude of B is 18 meters along the negative, so okay, turn this. It's good to actually draw a picture at least. So whoop, and then dun 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 dun. Turn this to 0. Whoops, there we go. And B is along the negative x-axis. So it's along the, what is, okay. Okay. So we don't need the ruler anymore. So that means A is this way, because it says along the negative axis. So I'm guessing this is like negative 18. Okay. Negative 18 meters. And this is vector B. Which means, what are B, X, and BY? Which is cosine and sine and theta. Now, part of me just wants to do 0 degrees, but I know that's not the actual degrees. Each of us has a QR code for name. Interesting. All you just need is a phone to scan it. Alright. Okay, theta. Yeah, it's like 180. And luckily I have my calculator this time. So, and R is 18 meters. Well, technically negative 18 meters, but I think either way it's... Because it's pointing along the negative axis. See, this is why it's good practice, because otherwise, now, because even though I've done this many times, I second guess myself a lot of the time. So, at this point, alright, so negative 18. Well, actually, I don't think it would be negative. I mean, when I think about doing R, actually, I mean, this would be 18 because negative 18 because it's pointing in that direction. Yeah, this would be negative 18. Like, X would be negative 18. Goodness. Meters. And Y would be 0, actually. Because then, yeah, there's nothing there. I mean, that's like usually this question 1, so it's usually the easiest one. Okay, oh, oops. Not that type of B. Lowercase b. Lowercase b. Okay, if Cx is negative 3 meters per second and Cy is 5 meters per second, find the magnitude of C and the angle that C makes with the positive x-axis. Okay. I think that should be easy, so in this case, that'd be 4 and you carry the 34. And I don't think we can reduce that anymore. 34 divided by 4, I don't think that would, yeah, that wouldn't equate to anything. I just want to make sure I did the math right, because usually when I do math, the arithmetic is always off whenever I do it. So, yeah, that would equal 14, you carry the 1, and then basically that would equal 34, yeah. Because it's 25. There we go. That looks nice. Okay. So we got the magnitude of C, which is square root of 34. And the angle, it would be arctangent. Oh, yeah, we got a negative sign under here, which means we're going to have to add 180 degrees. Okay. Actually, I have to make sure, hopefully, okay, good, my calculator is in degree mode. Okay. So, negative, the plus 180, 120 dot Well, I think we can just round it to the next significant figure, so it's like 121 degrees, roughly. So we'll just do that. Yeah, there we go. Okay, that looks about right. Because, like, what would happen if I just did this? That would be negative 59, so we do. Because I remember if it's a negative underneath the denominator, you have to add 180 degrees. Okay, so that's question 1. Let's move it down here, shall we? And I think 1.2 vector A has magnitude of 11. So this is an acceleration vector. That's my guess, because basically whenever I see like second per second, then I really assume that it's basically just an acceleration. Unless there's like another quantity that requires that those units. Degrees with the positive x-axis and vector B has Cartesian components Bx equals 4 meters per second squared and By equals negative 3 meters per second squared. Okay. If vector C is equal to A plus B, find the x and y components of C, and B, what are the magnitude and direction. Well, that doesn't look good. Direction of vector C. Okay, here we go. All right, so we have with an angle of, okay, so we have to figure out what A's x and y components are, because C is equal to vector A plus B, and AX is equal to R cosine theta, and AY equals R sine theta, and we know theta is 65 degrees with the positive x-axis, so we don't have to do any fancy like gymnastics with that. Okay, so we know that R is 11 meters per second squared. Okay, So that means we just have to punch the numbers into our calculator, which gives us AX, AY is equal to, boom, 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 65 degrees, 4.65, roughly. Roughly. And I think we just should put these curly well, let's just redo those. Roughly. There we go. Nice waves. Okay, sine of 65 degrees. That's around 9.97 meters per second squared. Meters per second squared. Okay. All right, now let's see. So we have to find the x components of these. This should be fun. Okay, so we'll just have to add the x components and the y components together. Plus b, because this should equal y and by. Usually on my calculator, I would end up calculating it to the t. So I would plug like the equations in for ax and ay, and then add it with so this one is equal to 8 point. There we go. Meters per second squared. And then sine of 65 plus -3. That gives us 6. Almost close to 7. Okay. Well, actually, this should be, what are the x and y components? So, okay. All right, what is the magnitude and what is the direction? Okay. All right, so the magnitude, I think we can get this. So the magnitude of C is equal to CX squared plus y squared. I think I'll just type them the way I rounded them on like what we wrote here. We'll treat it like a we'll treat it to be like a scientist. It's like, we'll round it to basically like 3 significant figures. If I use the wrong terminology, please correct me, guys. So we have 11.1, roughly. Okay, and the angle, that should be oh no, 8 should be down here. 8.65 should be down here, and okay, 8.65. That comes out to be 38 point. We'll round it at 38.9 degrees. Let's round to pi sig figs. Right, Pen? Right? You know what's crazy to me? I read a book called, I think it's called The Big Bang of Numbers. And the funny thing is that it's very cool and mysterious. Like, the author basically says, if you look at the endless digits of pi or the endless digits of any of the what's the word? transcendental numbers, I think. I don't know, I might be mispronouncing it, or I might be reading the word wrong. Like any of those numbers that have endless digits, you'll find like probably every verse that you've read in a book in those numbers. And like every number in there is more likely to have like every letter of the alphabet, every letter in every letter or sound in every language, and you can put every single book, every single like scripture that were in those languages in those numbers, like if you look past the decimal point. And I thought that was like very interesting and mysterious. I mean, they're just as mysterious and cool as the power series within physics. Let me just do that. And the answers to these are online, but I don't want to look at them until we get like a majority of them done, because I don't know if we're gonna get all of them done in this stream. We may or we may not. I don't think we're gonna get them all done though, because like there are, I think 12 problems in here in this section. They're 10. Okay, they're 10 problems. So we might get it done if I know what I'm doing. If I get stuck, then basically, you know, I get stuck and I have to learn more. So, you know, it is what it is. I am not an expert, nor would I try to assume that I am. No. Wait. We were on 2. We were on 3, not 4. Luckily, I caught myself there. Because I want to be able to learn as much as I can about vectors, because I want to get into tensors. Because tensors are the things that I haven't fully comprehend yet, because I haven't fully comprehend quadravariant and covariant components. I'm still struggling to understand those when it comes to vectors. Imagine that the y-axis pointed north and the x-axis points east. Okay. I mean, that's how you read it on a compass, so I don't think that's too hard to imagine. If you traveled if you traveled a distance r kilometers. I prefer meters because that's what you usually use in physics. But I'm not going to try to convert units. Straight line from the origin in the direction 35 degrees south of west. What is your position in Cartesian XY components or coordinates? Coordinates. That's A and B. If you traveled I know I don't have to write every single part of the problem, but this is a habit I've kind of developed for myself, because I always feel like I'm doing, like whenever I try solving a problem and I get too deep into it, I end up solving for something different. usually, and I forget to reread the question while I'm in this process of like solving the problem or solving a problem. Like, I know some people will say it's a waste of time to like rewrite everything, but I guess that's just basically how I am. Because I like to, like, when I guess the process of writing the directions down has stayed with me. I guess, like, rewriting the question sort of etches it in my memory better. So that way I'd be like, okay, so if I hear a problem similar to this from somebody or from somewhere, I'd be able to, like, go back and think about, oh, how would I solve that problem from that book that I read years ago? I mean, sometimes that happens. Like, someone would ask a question and then suddenly it just leads me to thinking about a set problem that I did, like, probably, like, years ago. And then suddenly, like, oh, okay, like, I think I know what we can do to solve this problem. Okay. Alright, so if you traveled a distance, let me just move this up. There we go. So if you traveled a distance, R is 22 kilometers in a straight line from the origin in the direction... Okay, so I think we're going to need the ruler for this one. I don't want to try to visualize what it is. Okay, 90 degrees, please. Thank you. Sketch. Okay, 0 degrees. Here we go, here we go, here we go. Whoop. There we go. And boom. And south of west. It's just I'm trying to think for a second, because now that I have the degrees on a ruler, I want to make sure it's accurate. Because we have to do 35 degrees south of west, so we're gonna have to do we're gonna have to go backwards. Because it's 65. Because if you do 180 plus. Let's see, so we have 90, then 180, and if you do 90 again, that's basically, yeah, that's like 370. No, not 370. What am I talking about? 90 plus 180, that makes it 270. So 270 minus 35. So this goes by the x-axis. So then 90 minus 35. I know it's taking a long time for me to like... 90 minus 35 degrees. That'd equal to 10. Cross out the 9. That'd make it an 8. It's 55. 55 degrees. Nope, don't move. Don't move. I just need to draw a line. That's all I need from you. Okay. getting measurements is as accurately as I can is usually like a bit of a tidbit for me. But luckily I was able to like figure it out. But it takes me a while. Alright. It's from south of west. Okay, so south of west. Okay. Hopefully I got the direction right. Because usually I would think that if it's the other way, it would be west of south. Yeah. I don't know, like someone could scream at me and basically tell me that, no, you got it backwards. What is the position on the Cartesian? Okay. So if we reverse this, right, so then we have 270 minus 55 degrees. That is if I have my numbers right. So it would be 215 degrees. So theta would be 215. And then we'll just call this vector A. So vector A. So AX and AY, that would be cosine 520. And then sine of 215. And those would equate to because it's below. Okay, I think it was like kilometers, I think. Yeah, I think it was kilometers, the units. And sine of 215, negative 12.6 kilometers. Yeah, what is the Cartesian coordinates? Hey, Famish, how you doing? It's okay. Typos happen to all of us, the best of all of us. I'm pretty sure that is, those are the right coordinates. Yeah, Penn Center, I don't know if you heard my question, but like for my streams, would it be okay if I use the questions that you posted in the real analysis course? If you don't, if that's not allowed, please let me know, because like I would like to actually try those problems like on stream. Yes, of course. Okay. Yeah, because I didn't want to do it without asking your permission, because you took the time to make the course and also like pick the problems out, and I don't know if you want to share those on your stream, so I wanted to ask first, because I think they're very good problems, and like, you know, I'm still struggling with the first set you set up for us, so I'm like, oh yeah, I need a lot of time with these problems. Like, I think like wrapping my head around a definition and how to interpret the definition and writing it in a proof form, that's what I struggle with. I'm struggling with, I think, another question. Please attempt and feel free to post your attempts. Happy to chat about them. Okay, cool. Yeah, because when I did that first question, I think it took me a while to actually actually do those. And when you told me I did well on the first two, I was like, oh, okay, cool. But the third one I wasn't really sure about. Because it felt right to me, but at the same time, I didn't think I structured it logically for like what the proof was asking for. Okay, if you travel 6 miles due south. Oh, great. Now I gotta pull out the ruler again. What fun! I mean, it's not like I hate the ruler. It's just that, like, you know, I just want to make sure. I'm a very precise person, so I want to make sure that everything is crisp and clean as it is. And like, you guys saw how fidgety I was with like the figuring out how many degrees I had to put in for the south of west. I mean, if I'm wrong about this one, then I'll just relearn what I just missed. But I think south of west is like that way, like when it's coming from south and it's going towards the west. that angle. Because actually, like when in high school, those directions kind of screwed me up when I was taking, I think, pre-calc. And I was like, oh, wait, it's the other way around. Because they don't go like, you know, like southwest or, you know, and we don't really say like west south or anything like that, at least in the States. The third one I didn't check close enough. No, it's okay. It's okay. Like, I know you're busy with other stuff. I'm not expecting you to check it like within like, you know, like within one seating. So, you know, it's okay. I know you're busy with other things. Like, you get back to me whenever you can get back to me. Travel 6 miles due south from the origin. Okay, so... And then turn west and then turn west and travel 2 miles. Okay. How far from the origin, in what direction is your position? Okay. So, we don't have to draw for the first one. I think we just gotta set the ruler up so it's like 0. Okay, 0 degrees. We'll just drag the ruler down here. So down here, we traveled 6 miles. 6 miles. We have to write it out because it's not meters. I can't just put M and say it's miles. No, that's meters. I've done physics problems like a couple times, like whenever I'm bored, and like I always never forget meters. And then 2 miles. And then I think we can get rid of the ruler now. So 2 miles. I know it's not to scale, but we're just gonna go with that. How far from the origin? Okay, so this one, we're going to have to add these vectors together. Okay, so we'll have vector A, which represents the 6 miles. So that would be -6 J. We'll just put J there to represent the Y coordinate. And then we'll put vector B, which represents -2 of I hat. So if we add these together, that would be just those coordinates. Okay. Now we got to figure out the angle and the distance, right? How far from the origin and in what direction? Yep. So we have to solve for the actual distance of this thing. No problem at all. Hopefully I don't eat my words. Probably I will. But that's what it means to learn. I can't get too big-headed. 40. Oh, that will be easy to reduce. So 2. Yeah, so that would be 20. No. What am I doing? I'm making more work for myself. It should be 4. 4 times 10. Then, oh wait, no, I was on the right track. What am I doing? I am losing it, guys. And that is the buzzer. But I want to finish this problem because I feel like we're just almost done with it. So we have that, and then we have to figure out the direction. So arc. I know my solution writing is like very, very messy. It's like, it looks like it's all over the place. Oh, I'm actually covering it. Oops. Let me just drag it on this side. Oh, now let's just put it in the center piece. There we go. All right, so we have 2 is the coordinate, and since 2 is still negative, we're gonna have to add 180. I remember this question, like I think I screwed up because I didn't do that, because I thought, oh, the negatives will cross each other out. Nope, you still gotta do it. You still gotta add the 180. 251.16 degrees. Okay. All right. Let's see. Let me just double check here. 4, 36, 40. Okay. All right. I think we'll just take break time now. Let's see. I think I lacking motivation because I don't understand matrices and missing some extent of research. Are you researching things, Famish? If you don't mind me asking. Like, what are you? If you are researching something, I actually want to know what you're researching. Oh yeah, guys, we also have a Discord server. If you guys haven't checked that out, like, I would like us to actually like talk there, like, you know, to exchange ideas, or like, you know, if you guys are like doing a master thesis and you just want to like explain your topic to like people that are like pretty much like, I guess, don't know the subject. Like, I think the best way to actually like learn something, you know, is actually teach it to someone else. And I think, like, you know, in our Discord server, we can exchange ideas and we can just teach each other what we know, and then realize that we can find some blind spots that we're missing. Yeah, I usually tend to extend, I tend to do extended research of, I don't understand something. Something I forgot to do in my studying routine. Oh, okay. Yeah, like for me, it's like, I think I learn better when I actually like teach someone stuff, but at the same time, like with math, I feel like I have to actually give myself more humility, because even though I know a little bit of Calc 1, I still have to like practice more. And I think like what I struggle with is Calc 2 stuff, because like I still don't remember, like, you know, I remember the methods. It's just that I don't fully remember the muscles to like solving problems, because I haven't practiced enough. Like, I remember the methods, like the disk method, the cylinder method, and no, not the cylinder method, the washer method, like all those different methods, but I haven't practiced problems with those. I should book. Oh yeah, here we go. I was like, where's my bookmark? I want to mark the page where I was writing the questions down. But yeah, if you guys want to join the Discord server, please join the Discord server. It's in the chat. And if you want to access the Discord server, if you don't see the link, just type in !! Discord server. I'll do that for you guys since we're on break time anyway. Please join the Discord server. Like, I think it took me a day to make it, but at the same time, like, if there's anything I need to improve on with the Discord server, please let me know if you join it. And let me know if the link is broken. Like, if the link is broken, then I'll put a new link up. My study routine is read over something once and go back and take notes in my own working of I can, and ask questions like why and how. Yeah. Like for me, I kind of write notes like a zombie sometimes, because I just take it. Like, I don't question it, which I probably should do. I guess it's because I was just too much of a, like, when I say good student, I don't mean a student as in like, oh, I'm so smart, like I get A's on the test. I was just a good, diligent student that didn't question things, and I probably should have questioned things a bit. I think it was because I was a very shy kid back then, and whenever I raised my hand and I asked a question, I would worried that I would hold the class up. Because I think one time in my chemistry class, I was asking about the reaction of soap, and then like one person complained, and like it made me feel very, it made me feel like I was disturbing everybody, so I didn't ask a question in class ever again. Well, like, not to an extreme, but I just felt like, oh, maybe I shouldn't ask like questions that didn't seem like it was relevant, you know. Because I think like I do have curiosity. It's just that I feel like my curiosity is not found until like someone asks a question revolving around that, and I never thought of the question. And I think that's when I get very, very enamored. I'm just gonna take a small cough drop, guys. Every time when I stream, I always take a cough drop. I think it's because I've gotten so used to like talking on stream a lot. Asking questions helps critical thinking. Yeah, like sometimes like I wish I was more critical when I think. Like, for me, I just get inspired more. Like, I basically would read something and I would get inspired by it instead of just question it. I guess I'm just not cynical. I just like to be inspired, and I think that's why math kind of inspires me. Like, I feel like when I like read math or like read physics, like I feel as if like, wow, I'm getting more in touch with the universe, and it's just a bunch of squiggles, numbers and squiggles. Like, I'm thinking for a second, because it's 10 problems, right? I wonder if we're gonna get through this whole thing on the whole stream, though. Maybe. Because I wasn't sure if I should just do the whole... Because we have 10 questions, and usually, like, when you're in school, 10 questions is usually like, that's no big deal. But at the same time, I don't know if I want to move on to a different subject. But at the same time, I probably should just focus on this subject, because it's just 10 questions, though. And plus, it will get my brain moving. The problem is that when you want to learn math and physics for their both sake, you realize that there's so many subjects that you don't know within both subjects, and you have to expand your horizons to basically learn everything. But you have to also learn the technicals of how those small parts work. So, you know, sometimes I just don't focus on those small parts. I guess I will have to go back and read over and then dig into matrices, since I was reading over and... Oh, okay. Yeah, I mean, like, it doesn't hurt to go back, because I'm actually going back to vectors, because even though I know what a cross product and what a dot product is, I feel as if, like, I don't practice enough problems to basically say, okay, now I can just, like, look at a problem and just solve it right away. Like how I would with factoring in algebra or something. And I think the more times you go back to a subject, the more you begin to understand what you missed the last time. And I think, like, maybe... I don't know about next stream. Next stream, we'll probably still work on vectors or something. But I am a little interested in power series, and like maybe a little bit of differential equations. But at the same time, like, I'm trying to like slow it down to basically like focus on like basically learning stuff. Because I think in this book, I think I got up to chapter 3. Yeah, applications to vectors. And then chapter 4 is about covariant and quadривariate vector components. This part, I like quadривariate and covariant components of vectors. I feel like I still have to understand a little bit more about them. And it's like I get close to understanding what they are, but I feel as if like it's just still slipping away from me whenever I get to, I guess, like kind of getting to the full understanding of what they're meant. And I think once I understand that, then I'll be able to like understand tensors a bit more. Like, I want to be able to understand tensors, because I know tensors are used in physics a lot. Because that way I don't have to worry about relying on coordinate systems that much. But if anyone is still in chat, like, you know, like, what are you guys working on currently? Are you guys, like, programming anything? Are you guys, like, just studying for class? Like, if you're studying for class, what are you studying? If you're in college, what are you majoring in? Like, is there any research projects you're developing in your major? Because I think with STEM majors, they have to do, like, some sort of, like, end of semester project or something. Or maybe a senior project on something. If they're like in their last year. And if you're on your last year, you know, or last semester, you know, like, good luck to you. Actually, like, matrices, like, I think the thing that I really hate about matrices is just like having to deal with like I think like 3x3s and like multiplying 3x3s. I think those are the ones that I get a headache with, because I'm so tempted to pull my calculator out because I don't want to do it by hand. Like, I think, like, even though I took a course in linear algebra, I barely remember things like about vector spaces and eigenvalues. I have to actually, like, and also linear transformations. I have to actually, like, practice those too. And I know, like, linear algebra is very applicable in quantum mechanics. So, like, those are a big list of priorities for me. Let's see. But yeah, hopefully you guys are like being able to do your own projects on the side too. Like usually for these streams, even though like I'm doing math, I don't really dedicate it as like I guess like I don't expect you guys to be doing math like while I'm doing it. I usually expect like you guys are doing your own projects on the side, whether it be art related or whether it be like programming or whether it be something that you're passionate about. You know, you could be just like knitting while I'm just doing math. I don't mind that at all. Because like I think like the best part of focus is when you know you're doing something that you really love to do. Although for me it's like whenever I do the problems and I get them wrong, I get very, very flustered. But I think who wouldn't? Who wouldn't get flustered? Not to mention I also have to stream on my other channel like tonight too. Like I gotta play like Genshin, like catch up with the events on Genshin, and then probably we'll move on to another gacha game that I'm behind with. And also like I want to thank everyone for the follows actually, because like we managed, you guys managed to get the channel up to like I think 21 followers, so I'm very, very grateful for that. I'm so glad that like my math channel is like being able to like get a small audience. Very, very thankful. It's those special words some math books use that confuse me. Yeah, like it sucks when like some math books are like very, very dry when they explain things, and I understand why, because definitions are very, very important in math, but at the same time you always wish that it wasn't a slog. Like there was a book in Amazon where it was called A Friendly Approach to Complex Analysis, but I took a look at the book and they were like, I think it was like a little bit over 200 pages, but I felt like that was kind of too short. But at the same time, I don't know how good the book is. So, you know, there's a part of me that's tempted to get it, but at the same time, there's a part of me that's like, oh, I've been down this road before. Oh, the Discord is invalid? Oh, okay. Let me just put a link. Let me just put a link in for you guys. I hate it when that happens. Whenever like I do like a Discord link, it sometimes expires or it goes it becomes invalid somewhere. Alright, let me see if this works. Oh, what the? Let me just see if I can get a link here. Okay, never expires. No limit. Generate link, please. Okay, why is it not letting me copy a link to my own Discord server? That's queer. That's weird. Yeah, for some reason I'm not able to produce links on my own thing. Why? Is it because I'm streaming live or something? Huh. Yeah, for some reason it's not letting me like produce a link for you guys. It just keeps saying it's hidden. Like use the copy button. Let me just turn off the study timer for a second, because this is gonna bother me. Yeah, now I'm not producing a link. That is weird. I'll have to figure it out. Yeah, sorry about that, Rex. I don't know why my Discord is not letting me produce a link for the server. Let me see if I have to, like, set something. Let me see here. Yeah, I don't know what's going on. Okay. I guess I'll have to figure it out later. Alright. But before we continue, guys, I will be right back. Just give me one quick second. Okay guys, I'm back. Alright. So now we will go into the second study session. Yeah, sorry about that, Rex. Like, I don't know why my Discord is just now being like very uppity today. Like it's, yeah, it wouldn't let me like even produce a link for you. Okay, I think I've managed to figure out what happened. Okay, I think now I can produce a link now. I had to press something on Discord, so hopefully that works. Actually, I'll try the link myself to see if it accesses it. Okay, there we go. Yeah, so I think that link is not broken, so I'm just going to quickly fix that. Let me see if this Discord link is broken. Yeah, it is broken. Okay. So I will change that on my stream elements just real quickly. Oh, no. Just log out of this one. Because I actually have two Twitches, two Twitch channels. One for my gaming channel and this channel. So let me just go to my timer. We'll just erase this link and paste another link. Then we'll hit save. And then we'll go to the chat bot, chat commands, and then Discord. I'll just change this link too, just in case. Because these links are not supposed to expire, and I don't know why they're, like, breaking. Okay. Okay, I think that's about it. So, I will just test it, just in case, before we move on. Alright. Okay, that link works. Okay. Alright, so as long as the links work, then that's fine. Actually, I want to check out this, You're in? Cool, cool, cool. I'm actually gonna check out this other thing that, Rex recommended. Because I'm actually checking out the Mito browser. Let's just see if it works. I don't know why it's like asking me for like oh, I have to like register on this. Okay, never mind. I'll probably check this out later. Actually, I didn't think I had to like register or anything. Oh, okay, okay. Yeah, like this is my second channel, Rex. Oh, hello, Phobo Streams. How are you doing? How are you doing? Yeah, we're just about to, like, get into the second study session. We're doing vectors today. But how are you doing? What was the best part of your day so far, Phobo Streams? And hopefully I'm pronouncing your name right. Actually, I'm kind of wondering how you got that name. Like when I first saw the first two letters and I'm like, Pho. Like get some pho at the restaurant. I'm okay. Feeling sick. No S at the end of the name. Oh, okay. Yeah, yeah. Yeah, I realized that I said dreams by accident. I think it's because it's like I like, you know, like when people say like I have dreams. Anyway, let's get into the second study session, shall we? I've stalled out long enough. But luckily I managed to get the Discord up for you, Rex. Okay, so I think we are on number 1.4. Let me just erase that. That didn't look nice to me. Yeah, I'm sorry you're feeling sick, Phobos. Recover at your own pace. What are the X and Y components of the polar unit vectors r hat and theta hat when... Wow, my handwriting is just like... I think it's just because I'm just like, I just want to rush through these problems. I probably should like slow down. When theta is 180 degrees, B when theta is 45 degrees. And when theta is 215 degrees. Okay, polar coordinates, polar unit vectors. So I think r hat, I'm trying to remember, so I think it's cosine of theta I hat plus sine of theta j hat, and I think this one is the opposite, sine of I theta plus cosine of theta. I think those are the coordinates. Let me just, let's see, polar unit vectors. Right, okay. Yep, that's correct. Okay. We're correct on that. We are correct on that. Okay. So, for A is, theta is 180, meaning that we will get -1, so negative I, and then we're going to get 0 on that one. So it's a negative I for that one. Let's see, what are the x and y components of the polar unit vectors? Okay. And theta for that one is, that one is also going to be negative j. So it's going to be negative j hat. Okay. For B, 45 degrees. Okay, so r hat is going to equal to, I think it's supposed to be the square root of 2 over 2. I hat plus, yeah, so j hat, and then the unit vector here, then that's going to be minus 2, and then plus j hat. That I remember from trigonometry. The one thing I have to figure out is, like, how is it that you prove, I think, the dot product and the cross product with the laws of sine and cosine? I think I saw the one with cosine, and that one made sense to me. But the one with the law of sine for the cross product, that one I have to, like, relook at. So do this. Okay. So 215 degrees. Now I gotta find what multiple of that is. So let's do 215 minus 180. Done. That should be 3. Yeah. So 35 degrees. Oh. So that means we're gonna have to do 30. No. I mean, we could, because the thing of it is that I thought it would give me like a simple fraction, but unfortunately we're gonna have to rely on decimals here. Yeah, I have 2 discords. Yeah. I'm guessing you came from my my original channel. This one is more like dedicated towards math and physics. Yeah, like if you guys are curious, Uncle Talks is like my original channel, Twitch channel. That's like where I play games and stuff. Like if you guys want to give that channel a follow, if you just want to like watch me play games, that's also another place you can check out. Let me just type that in for you. That's my Uncle Talks Twitch channel. So 215 degrees. so that would be negative. Oh, I gotta actually click on my tablet here. There we go. All right. So negative. Let's just round it up there, and then sine 215. That'd be negative. Right. Yeah, that works. No, I'm the one who dragged you from the Mendelblood channel. The amazing member. The amazing man member. Let's see. So negative sine times. So then we get this one on this side, and then we already have cosine, so it's negative 2j hat. Okay, so circle this, circle that, and circle this. Okay, not bad. The other Discord invite is also invalid. Wait, what? I mean, it works fine when I click it. That's odd. Okay, we are on number 5, I think. Yep. The matrix or matrices can be best described as a table, a rectangular array. What does this mean? It means objects can be arranged in rows and columns to. Now I understand. Okay. As long as you understand, then that's fine. Alright, you need another link, Rex. I swear these typos. No, it's fine. It's fine. I'm just glad you're like active in the chat. Alright. There's another link to the Discord server. Okay, let me just click back in here. Let's do number 5. Let's drag this up. Like so. Okay. Now number 5. Oh. Cylindrical coordinates. Time to practice those. Cylindrical coordinates. Oops. Oh, the other Discord? You mean my Life Reaches Discord? Like the one for my Uncle Talks channel? I think about matrices, oh, okay, okay. probably would have to fix that too, actually. Yeah, that's a link to my other Discord, the Uncle Talks Discord. But I usually like activate that for my other channel. But there you go, Rex. See if that works. Let me just click for myself. Okay, yeah, it works for my end. So I think it should work for you then. Okay, if 2 meters and 35 degrees and z equals 1 meter. Yeah, sorry if I was misinterpreting that. I thought you meant you weren't able to access my my math spellbook Discord server. For all you guys that joined the Discord server, thank you. Like, my hope with the Discord server is that we just exchange ideas with each other and, like, you know, learn from each other and, like, you know, basically gain some input about whatever our educational interests are. Share those. And if you guys have any ideas of, like, what I could add to the Discord server, any of them, just let me know. And then I'll basically, like, see if I can, like, put stuff in. Yeah, the math spellbook one is basically just for us to like connect and actually exchange ideas, like, or maybe like, you know, if one of us thinks that we can help one another through there, we can always do that. Meters. What are okay, so yeah, I write this way because I'm left-handed. I didn't realize it was that crooked. I was like, oh my goodness, like, wow, I write very slanted. But then again, I'm also trying to read something like a little bit like further away from me. Okay, so if R is 2 meters and 35 degrees and Z is 1 meter, what are the X and Y coordinates? Okay. So X and Y, those are going to be right, and then Z is just going to be Z. That's going to be no problem. Pull out the calculator. Hey Fizzbuzz, how's it going? How are you? How are you? How are you? Actually, come to think of it, I forgot to like put a link to my channel on like some physics discords. Was heck yeah, loving the math community. Yeah, I'm glad you're here. What was the best part of your day so far, Fizzbuzz? Things are going well, just being lazy instead of working. Well, I'm glad you're here, because if you feel like you need to work on something, you can just pop it up and basically you can just work alongside with us. Or if you just want to just chill with us, you're free to chill with us. Just think of this as just awesome office hours. Even though I'm not a graduate student or a professor by all means. I think anyone in the chat will be worthy of that title, but not me. Like if I were like a teacher, I basically say like, yeah, you guys basically come to me for a grade, or come for me to critique your skills in a particular subject. I'm here to earn the name of professor from you guys so that I can earn the respect that you guys think that I'm worthy of. it's like it was running well in my head, but then I forgot what I was going to say. I mean, that's how I would be if I was a teacher. Like I would be like, it's the student's responsibility to like participate and like try to earn like, you know, I guess like a good placement for themselves to know where they stand in the subject, and it's like my responsibility to be worthy of like being a good teacher to them. Like the reason why I would be a teacher is like to earn the title professor from you guys. That's basically what I would say. Math hobbyist is the best. I'm still trying to figure out who Penn Senator is. But hi, it is me. I actually want to see what you guys said in the chat, like if I missed anything. Oh sorry, your name is so similar to someone else. Right, okay, I didn't miss much. Okay. Alright, so I think we're done with part A, right? So let's see. Yeah, I think we're... Oh, that's the thing I hate about my tablet sometimes, is like you have to click it to activate the mouse. But then again, like the tablet is like, hey, pay attention to me. You're supposed to pay attention to me. And it's like, all right. Sheesh. Okay. So now we got to figure out what R and so X and Y and Z are equal to 3, 2, and 4. Okay, so what are the R and... Okay, so R, I think we know what that is, because this is cylindrical coordinates. Okay, so we don't have to worry about Z in this case. And I think for phi, oh, you also stream Fizz Plus? I did not know that. I will actually give your channel a follow then. I'm trying to like follow as many like as many math channels and like science channels as I can. So all right, so 2 over 3. Okay, we have no negative numbers. Great, we don't have to worry about adding. So 4 meters. Yeah, meters. And so we have 33.7 degrees. And this one is 3 squared plus 2 squared. That gives us 9 plus 4. 9 plus 4 equals 13, square root of 13. And I believe those are our coordinates. Seems about right. Yeah, because like y over x, right? I'll just retype these just so cosine of 35. And I'll check in the book to make sure that I wrote everything correctly. Right, yeah. Yep. We wrote everything correctly from the question. Sine 35. Yep, it looks like everything checks out. Doing well on diagrams, working well. It's awful. Oh man, I actually probably should practice some is it LaTeX or is it LaTeX? Like, how do you guys pronounce it? Because for me, I would say LaTeX a lot, but I'm probably like pronouncing it wrong. If I'm pronouncing it wrong, let me know, please. Because I think I got a course on it on Udemy when it was like cheap, when there was like a sale. So like for me, it's like I think a part of me wants to learn it because I want to type my story using LaTeX. I say LaTeX. Oh, okay. But I heard others say LaTeX. Oh, okay, so it's versatile. Okay, it's like tomato. Okay, that's good to know. Yeah, part of me just wants to like type my story in LaTeX because like I want my story to actually have equations in it. The thing of it is that I haven't seen any other, I guess, font is able to type in math equations very nicely other than LaTeX. But I have to practice actually typing LaTeX, like to make everything look nice. The thing of it is that, like, I've been thinking about the story for so long, but the problem is that I have to make the battles in the story, like, very, like, it's, like, very technical, but at the same time, I'm trying to make it so it's, like, for a broad audience. The problem is that I don't know enough math or physics to actually like make it so that I can think of like awesome scenarios that the characters find themselves in. Like, I'm still trying to develop the power system they use. Sometimes I just say tech, not to offend anybody. I say la, just so it doesn't sound like, literal, like, tech. That's fair. Have you read any No, I have not. Actually, the thing of it is that when it comes to fiction authors, I tend to, like, read it for, like, a good while, but then I end up, like, if the story doesn't engage me, I end up, like, putting it down. I mostly read a lot of nonfiction. Why, you ask? Fizzbuzz, like, why you ask, actually? Yeah, I've heard of, like, you know, Brandon Sanderson and all that stuff. Okay, I'll probably take a note of that, actually. Oh, hello, Jeff C. Groves. Welcome. What's the best part of your day so far? Oh, thank you for the follow, Jeff C. Groves. Much appreciated. Yeah, because I remember you would pop up on some of the math streams that I would occasionally drop in on. He's very active on social media, so if you add him, we'll reply. Oh, okay. That's good to know. Actually. Because I'll be honest with you guys, like, I think I got, like, a limiting math parameter that the main protagonist could, I could use in the story so the main protagonists don't seem overpowered. But at the same time, it's like, I still have to develop, like, actually scenarios where they actually have to fight their enemies using, like, math and physics. Well, sadly, I've been getting caught up on stuff, hoping to get some GIS done later. What is GIS, if you don't mind me asking? Cylindrical coordinates, mitigator map. I love it. I'm glad you you love it. Oh, geographic information systems. Oh, what is it that you do, Jesse Groves, if you don't mind me asking? Because it seems like you're doing something pretty interesting, or something that's like very intensive. Groves information system. Wow. I mean, that sounds like a company if you want to make a company out of that. Are you familiar with Voronoi diagrams? No. Please share. Please share. Jeff is preparing to be roasted. Oh my gosh. Multiple things, but hopefully I'm pronouncing it right. Voronoi diagrams are one of them. I'm so glad you guys are making the chat very active. And all you guys that drop follows, I always appreciate it. I didn't like, because I started the channel like around like, I think like 2 weeks ago. And you guys are just like making me smile. Like basically we're all, like you guys are gathering here and like even though I'm doing math that probably might be totally simple to you guys, I feel as if like, wow, we're all gathering and like, you know, just like talking the breeze and just like working. It's like we're scientists in a lab just talking the breeze while we're just messing around with beakers, just getting our job done. Or maybe just mathematicians just talking and we're just like letting our brains work in, what is it? Multitasking mode. Show that R hat points along the x-axis if... Oh. Okay, is this a proof question? So... Well, not really a proof question, actually, because now I remember what it was. So... This is it, and then... Wait. No, it wouldn't be... It would be this. Yeah, there we go. Because it's cylindrical coordinates. So then R, and then if it's 0, then that means, and then sine would be 0. Points along those, and that's our proof of it. Yeah. Pretty much, yeah. That was pretty simple. Suppose you color the world with red where you're closer to England, blue where you were closer to America, and green where you were closer to France. Oh. So if you were closer to England. Oh, okay, so basically the colors are like a close proximity to the location that you're centering in on, right? Because you said closer to England or closer to America or closer to France. Right? Oh, okay. Oh, I wonder what the applications are for that. Interesting. And actually, what branch of math do you use that in? Or if it's like involved with something else other than math, please let me know. Like if you guys know like more technical stuff, like I always like am intrigued to like find out what it is that you guys do. Like if you guys are doing like coding or something for something that involves like higher levels of like computer science or math, like I'm always curious about that. In what direction? Oh, okay. I don't know why I wrote the question twice. I think it's because I'm just super engaged with you guys. Because you guys are just feeding me all this knowledge and I'm like, oh, I love it. Okay, so or phi. Okay, so we're at 1.6. Okay. So boom. So it's spherical. So it should be. Oop. So it should be negative sine. Right. And if it's 90, that means it will be negative I hat. Yeah, so it will be negative I hat. What direction is the show? It'll be pointing down. It'll be pointing down at the y-axis. No. What am I talking about? No. It'll be in the negative x-axis because it's I hat. I gotta like bang my head sometimes. I'm like, what the heck am I thinking? Hopefully I got the unit vectors for like the spherical coordinates right. I mean, not spherical, cylindrical. Because the cylindrical coordinates, I don't think they're different from polar. Yeah, they're not. Nope, they're not. Okay, that's good to know. Right, countries are especially polygons on the surface of a sphere. I'm learning as I go along. Found KD trees are very helpful. Did you say... do you know... no, I do not. Merriweather? I just say random stuff. Like if you hear me say like bazinga or something like that, like don't be surprised. I say like a lot of ridiculous stuff when I'm like doing stuff. Especially when I'm deep in thought in something. Another mass streamer says boom boom a lot. Bazinga Sheldon, yeah. Like, for me, I guess I'm just like an envious intellectual. I want to be like genius, like someone that's close to genius level, but I know I never will get to that level. Absolutely not. Like whenever I see like a movie or something of like a character, whether it be Einstein or someone like intellectual doing like a math equation on a board, I would probably replay that scene over and over again. Because I always remember the scene from I think the movie was called Serious Man, and I think it's about a professor of physics, and he's like dealing with a lot of problems at home. And like there was this one scene when he was just writing on a board for quantum mechanics, and like I practically watched that scene over and over again. And there's actually a course on Udemy where they teach you like quantum mechanics without the need of like partial differential equations. They even teach you calculus. The person that made the course, they teach you like the basic calculus you need. And you don't even need to know like differential equations or partial differential equations. I mean, it's sort of like a course that kind of does spoon feed you a bit, but I liked it because it allowed me to engage in quantum mechanics without having the need of a higher level of maths in order to like get to the subject. You get what I'm saying? Of course, I have to review that course because I haven't done it in a long time, actually. I finished it, but at the same time, I felt as if I have to practice more on actually doing it for, like, you know, to remember the content. I think it was fun when we actually was learning about the wave function. That was actually pretty fun. Maybe I'll probably do, like, because they also give, like, question sheets, so maybe I'll probably do that one day on stream for you guys. A little bit of quantum mechanics. Just for fun. Without having the need for like higher differential equations or partial differential equations. Okay, so there's nothing else with 7. Okay, I thought there was going to be a part C. Okay. So like, see. A... In spherical coordinates, find x and y. Oh. Now we're in trouble. Now we're in trouble. Because spherical coordinates, I never fully memorize these. I don't want to look at my notes, though. I don't want to look at my notes or the book, because I want to try to remember it by... I want to try to remember it. Because I know R is the square root of x and y and z. Let's see. If we have a situation where we have the same number of rows and columns, will be considered a square matrix. Where we were to add or multiply any two square matrices, the order of the resulting matrix remains the same. Right. I think adding matrices are like... I mean, they're a bit of a hassle, but at the same time, it's not as hard as like multiplying them. As long as you're not multiplying a 2x2 with a 3x3 is something, something weird like that. Right. Yeah, doing extensive research is helping even if I don't know how to do said problem. I know it will be useful. Yeah. I always love those problems where it's like you're trying to think of it and then suddenly like you thought of something completely random and then like suddenly that random thing actually leads you to the solution. One, can we hint to what definition are you using for theta and phi? Conventions differ. Conventions? Because I think, like, for spherical coordinates, they want it in r, theta, and phi, or phi, however you pronounce it. I think it's phi, you pronounce it that way. So, spherical coordinates find... Oh, wait. Oh, I have to find the Cartesian coordinates for this one. Okay, so we have to find x, y, and z for this. So r is 25 meters, 35. So to answer your first question, Jeff, if you feel like I'm struggling too long, you're more than happy to give me a hint if you ask me first. Because I am kind of stubborn when it comes to problems, because I'm like, nope, I don't need a hint, just give me like a few minutes, and then a few minutes it turns into 30 minutes later. So yeah, so if you feel like I'm taking too long, you can give me a hint. Oh, why is spherical coordinates so complex? But then again, it's not a sphere, so that's why. But still, I'm like, how do I derive it easily in my head without having to like memorize it? Like, that's the thing about spherical coordinates that gets, because I know they use spherical coordinates in general relativity, and I feel like I want to remember it, but at the same time, I just don't want to bring up flashcards every time when I'm trying to remember it. Because, let's see. Because technically r is like x squared plus y squared plus z squared, the square root of all those. I remember what r is. It's just... How do I get in reverse? That's me, that's theta. Oh, okay. Meta hint, draw a reference sphere. R is the distance from the origin to a point. Okay, we'll do that. Because you guys are trying to teach me, so, you know, I might as well listen to what the professors are saying. I would say you guys are professors. I think you guys are worthy of the title in my book. Let's do 45 degrees. Well, actually, I should do it on both sides. There we go. I thought I was like, why isn't my thing like showing? 0 degrees. Boop. Yeah, there we go. Lovely. Okay. Move that. I'll try my best to draw a sphere. It's not gonna look that great, but we'll just... This is the shading for like it to be 3D. I don't know. I'm just basically just making up for my bad drawing. Okay, so I think like this, and I think this is theta. I think. Because I really don't want to look in the book, but I might have no choice but to look in the book. University of Maths Spellbook PhD. No. I am not worthy of being a professor. No. I feel less stressful. I'm glad you're feeling less stress. Are you familiar with geo? No, I am not. Just a question, no need to do it here. Draw a point on the sphere and then a vector from the origin to that point. Okay, so you're using theta as the angle from the z-axis. Yeah, I think that's how it is in the book. That's what I'm trying to remember. I could be wrong, but that's what I'm thinking it is. Let's just draw this point here. Wow, I should erase some of this. Yeah, there we go. And then we'll just draw the point right there. So this would be considered R. Wow, that R looks so sketchy. Actually, I should have just wrote it down here. I guess we'll just put a little arrow on top there. So I'm guessing theta would be, or no, phi would probably be like the angle from like the bottom. I think. My bad, you should check the book. The convention I use is different. Oh, okay. Yeah, the one thing I never really understood, like I think for physics and math, they switch it around. Like phi and theta, they're like switched. And I'm like, why do you do that? Oh, okay. So phi is right here. Yeah, I was right. So basically it's from the z-axis. I guess since we have the book open, we might as well just look. Okay. Alright, spherical coordinates, you beat me yet again. And we might as well write the other coordinates. So I was right about the spherical coordinate for R. Theta is arc Z. It's always funny because whenever I'm doing these study sessions, every time when I time myself, I'm always working in a problem as soon as the clock goes off. And I'm like, no, I gotta finish this. Don't go off when I'm not finished. And then for X coordinates, for the wow, finished just on time. Nice. At least someone did. At least someone did. Yeah, cosine phi. And I think it's because it has two angles. That's why I always forget these things. And I always forget which angle is where. So I don't know if, like, the way they wrote it, I don't know if this is the physics way of when they write theta and phi, or is this the the mathematician's way of writing it. So anyway, guess we gotta pull out the calculator and then find, yeah, we gotta find the coordinates for those. I mean, this is, I mean, if you remember it and you just basically remember the the conversions, then this question is relatively easy. But I'm trying not to memorize it, but at the same time, I guess I might not have no choice but to memorize it. Okay. 25. Oh, we're already working on A. So we just got to write down the answer. So the x-coordinate, x and y. So we have 25 times sine of 35 cosine 110 90 and 25 sine of 35 sine of 110 actually it should be a 5 here, round it up, and it's just cosine of 35.5. Okay, so that's for A. And then for B, so basically for R is practically the easiest one. It's just 8 squared plus 10 squared plus 5 squared, or 15 squared, 19.7. Okay, so for theta, we have to do... Oh, okay. That actually made it easier. I just have to... Like, that's the thing I love about calculators. They remember everything you type in it. I didn't have to, like, retype a mess. Let's see, Z is, yeah, 15, so, yeah. Okay, so that's 40.5 degrees. Let's just drag this up here. And then, oops. And then, arctangent, 10, 8, 51.3 degrees. Okay. Now I can actually engage in a break. Okay, so I think I might do another study session because we just have 3 more problems to go. It just kind of sucked that I had to like look at the book for this one. But I guess you can't remember everything. Yeah, I think it's because, like, for this, for the coordinates, for spherical coordinates, there's 2 angles, and whenever I try to memorize it, I forget which angles go which. So I have to remember that x and y are 2 sine of theta, and then basically the y one has 2 sines in it. I mean, that's a lot of memorization. I honestly shocked by how fast I learned stuff. Like, yes, I might take some time, but have no issues. I used to have good memorization skills as a kid in 6th grade. I used to do what I'm doing now, just write stuff in a notebook. I guess that's why I'm still doing it. Yeah, probably. Yeah, because we have like 3 more problems left to go, so I'll probably just complete this part anyway. This part of chapter 1. But yeah, like, it's like practically like, I think like if you have a really good memory, it just like really helps you with like with a lot of things, because you don't have to worry about like missing track. But I don't really like envy people that have photographic memory, because the thing of it is that if they can't forget, then I think it causes them a lot of problems, because there's so much things that they keep in their head, and they know they want to be able to delete everything that's like not really relevant. Actually, I probably should just write question 8 while we're on break, so that way I don't have to rewrite it during stream. But hopefully you guys are enjoying the stream so far. Hopefully you're getting stuff done, or hopefully you're just enjoying the vibes of the stream. Because even if you're not doing math, I just would like you guys to just do the things that you would feel like you need to be productive at, especially if it's something you really want to do. So that way you feel like, oh, I'm actually doing this not alone. I'm actually doing the task that I love with somebody actually doing something that they love, you know? I never knew I had this skill since I hated school, but glad to know I still have it. Nice, yeah. It's always good to appreciate what you can do. Everyone has their own technique, which is fun. Yeah, exactly. I think like the best way to study is just finding your own way of studying, because the thing of it is that the things that I love to study, like I know with math you have to be in a quiet space to like be able to do it, but for me it's like I have to be doing like something else with math. Like I can't just turn off everything around me and just like do math. Like I practically have to have like anime playing in the background, or like a show that I'm kind of partially paying attention to like in the background. I don't know why, it's just like good background noise. It makes me feel like I'm not doing it for school or anything. It makes me feel like I'm actually just doing it for fun. Which is probably why I was just an average student. I was not very like an straight A student. I was just average. Because I would just practically do my homework while watching television back in the day. Okay, let me just check if I wrote that correctly. For spherical coordinates, show that points along the negative. Great. So I have to actually practice more spherical coordinates, because I ain't gonna remember the unit vectors or the coordinate conversions for those. But I think with you guys, like I was managed to like actually re-look at the spherical coordinates again. Yeah, so I have to remember that. I love watching TV shows. I use it as a motivation. Say I finish reading through matrices, I'll watch some and then save the rest after I get through the textbook of matrices. Oh, okay. Actually, Famish, like do you mind if I ask, like, is this project like for like coding or something like that, or is it like for something like just for yourself? If you don't mind me asking, because you keep bringing up matrices, and I'm like, are you doing like linear algebra? If you don't mind me asking, or is it something totally different? Oh, computer information systems. Okay. I see. Oh, for your associates. Okay. I see. Yeah, my one of my old college friends, they're trying to get an associates in computer science, but it's intermediate algebra. Oh, okay. I think like if you learn linear algebra, like you learn matrices a little bit quicker, because that's like the first part of the course. But then again, like, you know, like you have to learn those quick in order to do linear transformations and stuff. Linear transformations I barely remember. Like I took a linear algebra course, but then it was online, so like the problem is that I was working at the time, so I was like, I just wanted to get the assignments done, and I wasn't focused on my learning, which I probably should have. It's like, I felt like I just basically just breezed through the course, like, just basically just looking stuff up. And I think that's why, like, for me, it's like, doing school is like, kind of like, takes like, the building of my learning, like, off by like 50%. Because I'm just focused on passing the exams, not focused on my own learning experience. Let's carry this up over here. But I like learning even if I wasn't in school. Yeah. I think like that's how it is in life though. Like when you're actually getting older, you have to learn how to teach yourself a lot. And like that's really hard to do because when you're already an adult and you're actually like working, like a lot of people are like, I'm working now, I don't have to go back to school, I don't have to like pick up all this stuff that I hated in school, why do I have to learn? But the thing of it is that if you constantly learn throughout the rest of your life, you begin to develop skills that you probably wouldn't have thought that you would be learning because you were open-minded enough to actually learn those skills. I mean, like, some people are like, well, why bother learn math after school? Because, like, you're not going to apply that math anywhere. Like, if you don't want to get into programming or anything. And, like, true, but at the same time, it's like, it's just fun. Like, I actually able to, like, solve problems and I'm able to think abstractly about things. Does that mean it's going to apply to everything in life? Or, like, I'm just going to be the supercomputer? No, it just means that I just have fun. I just basically do these problems and I'm able to think a little bit differently. That's all. But, you know, some people respect their intelligence and some people just want to let it, like, you know, let it linger. They just want to turn it off so they can actually just enjoy their life, you know? And that's not a bad thing. For me, I just can't see a life where I'm just not learning things. Because it just feels like it would be so much more boring if I wasn't learning anything. That's what I did. Yeah, because, like, I think, like, I was mostly focused on editing. Oh, okay. I see. Editing is fun, though. Like, if it's for short videos, like, I think it's a lot of fun to edit things. The thing of it is that I don't like editing long videos, because that takes too much time for me. Like the first video I uploaded on my YouTube channel was, like, the Game of Thrones, math video. That one was fun to make. I want to do it on the side, maybe some freelance work. Yeah. You can apply, like, different skills. Okay, break time is over. So before we get into the next study session, I will just quickly use the bathroom. So I'll be right back, guys. Alright guys, I'm back. Alright, now we'll start the timer right now. Okay. Spherical coordinates show that theta hat points along the negative z axis if 90 degrees. If theta is 90 degrees. Okay. Now, yeah, I'm gonna look in the book because I know these unit vectors are gonna be hard to memorize. Here it is. Yeah, they're very long. So r hat is sine of theta cosine of phi I hat plus sine of theta sine of theta j hat plus cosine of theta k hat, and then theta cosine of theta, then cosine of phi I hat plus cosine of theta sine of phi j hat sine of then that's going to be sine okay. Wrote those down. Okay, before I actually get to the question, I want to see if I can properly memorize this. Okay, so the sine of phi and the sine of phi and the cosine of phi, they don't change their placement in the first two unit vectors. Okay. The third one looks like it takes like the derivative of cosine, which is negative sine of theta. Okay, so the pattern I can see is that basically the first term switches, and then the second term in the second and first terms of both sides, they don't switch. Okay, so maybe memorizing it might be not as hard as I thought, but we can answer the question now. So let's take a look. So if we have theta, so theta is equal to 90 degrees, so then we have 0 I hat, and then another 0 j hat, and then minus sine of theta, which will be 1, or k hat, negative k hat. So in all, it would be negative k hat. So that's the proof. Well, not proof, but that's what we needed to prove. If sine was negative, if theta was 90 degrees. Oh boy. Spherical coordinates, I think, is like gonna be like the of my head. But I know I have to learn it because obviously, like, I think spherical coordinates are great for general relativity. But then again, there are other coordinate systems there too. So if was also 90 degrees, what direction are... So I'm guessing they're asking if both these two are 90. What directions r hat and theta hat? Right? That's what it said in the book, or did they said phi hat? Nope, I wrote that wrong. It's supposed to be phi. Because I thought that was a little funny. Because, like, why are they just asking about theta? Okay, so we have 0 I hat. So we have j hat, because that's going to be both 1. And then we get 0, yeah, we get 0 k hat. So therefore it would be just j hat. And then for, well, technically we would just get, like, for like theta hat, we would just get k hat. And then for phi hat, we would get 90 negative I hat. So r hat would be j hat, and then theta hat would be negative k hat, and phi hat would be negative I hat. Okay. I mean, we had to look in the book to find out what the unit vectors are, but I think we practically solved that. Okay, so the next one, number 1.9. Let's see. Oh, nice. It's a physics application question. The magnetic field around a long, straight wire carrying a steady current I is given in spherical coordinates. Jeez, that looks terrible. Coordinates by the expression B is that an I or an L? I think that's an I. Okay. I was like, that doesn't look right. And the current, and then over, and then phi. Okay. Where mu naught is a constant and r is perpendicular. Wow. Perpendicular distance from the wire to the observation point. Find an expression for B in Cartesian coordinates. so. Okay, so we got, so it's b is equal to mu naught I over pi r. Okay. All right, so we got phi hat. I think this one is like that, and all right, so let's actually try to remember. So it's r hat, theta hat, and so I think this is sine of, negative sine of theta plus cosine of theta j hat. I think that's the unit vector for that, right? Yeah. Cool, we memorized it. Okay, so theta hat is, not theta hat, phi hat is pretty good. Okay, so now I'm slowly trying to exercise my memory of it. Okay. I mean, I've seen it multiple times, but it's good to actually like see that I'm actually getting results. Okay, so I think that's the way it's supposed to look, I believe. Because I think that is in XY coordinates. Okay, so I think we have one more to go. I don't know if we're getting them all correct, like, but we will do our best to see. Okay, so plus actually this is like much easier than me writing in my fountain pen, because sometimes when I refill my fountain pen like of ink, it doesn't want to write, and then I have to constantly just write with it, just hoping that the ink will come out. But then again, whenever I try to write with my fountain pen, it always like leaves like ink on my hand because I'm left-handed. I mean, I wish like writing was so much easier if I was like, because like I think like there's a lot of people that are right-handed. It just kind of sucks that like when you're left-handed, like if you're writing with something that doesn't dry very quickly, like it gets on your hand, and I'm like, oh my gosh, very monotonous. Okay, so this is like basis vectors. And if I remember, basis vectors are no. Excuse me guys, sorry about that. And then the magnitude. And then I think this one was easy to memorize. Then basis vector and E3. Okay. I may have to go for a hot dog and a drink. I should reward myself. Yes, please. Reward yourself for a good day's hard work. Yeah, so here we go. So this is 5 squared plus negative 3 squared plus 2 squared. That will equal to 25 plus 9 plus 4 over, oops, no, negative, negative, negative. So that would equal 13, 13 plus 25. Yeah, 13 plus 25, that would equal 38. Yeah, so, okay. And I'll check with my calculator so I'm not doing the arithmetic wrong. There we go. Yep, I was correct. Minus that, plus 2k, which means that the basis vector is, oops, minus 3. I ain't gonna simplify the square root, because I think we already did our jobs there. We will move this up a little bit so that we can write the rest. And the next vector we have to deal with is j hat minus, so that means it's 1 plus negative 3 squared, which makes it 10. So 10 squared j and so we have 2i plus j hat minus 4k. Okay, yeah, that's also what the way it's presented. So 2 squared plus 1 squared plus negative 4 squared equals 4 plus 1 plus 16, 2i hat plus j hat minus 4k hat. Therefore, 5 plus 21, so 2 hat plus 1 over, well, we just put j hat there. I mean, no, that doesn't look nice. I'd rather have it here. Minus 4 k hat. Okay, 4 plus 1 equals, yeah, 4 plus 1 equals 5, and then plus 16, yeah, that would equal to 21. So these, oops, so these are our answers. I probably should box these so that we can see them better. Okay, never mind, no hot dog for me. Too cold to walk just for a hot dog. Fair enough. Okay, so we are done. We are done with those problems. Now I think we can probably just check if they're correct. We still have like 25 minutes. So we might as well just check them out. So let's just zoom out so we can go back to problem number 1. Okay, problem number 1 here. Okay, now I'll just go onto the website. Students Guide to Vectors and tensors. Oh, no, that's the oh, there's an actual PDF version of it? I would have... Actually, I could probably, like, put this on my computer, actually. That way I don't have to bring the book into the office with me. I didn't realize they had an online version of it. Vectors and tensors. Save that. So I'll probably like pull this up the next time I'm working on this book. So do that. Okay, let's find the answer guide. Right here. There we go. Problems. Problem 1.1. Full solution. Full solution A. Yep, we got that right. Nice. So guess we'll click back here. We'll check mark that. Full solutions for B. Yep, that's correct, and that's correct. Nice. So that's checked. So this is correct. So let's go into continue to problem number 1.2. Oh, no. Didn't mean to do that. Drag it like that. Okay. Let's see, first solution A. Okay. Like, I saw that I boxed like one thing and I was like, wait, did I get it wrong? And then when I looked, I was like, oh no, I boxed the right thing. I boxed the right thing. I just boxed A and yeah, so okay, so we got that problem. Okay, so now on to full solution B. Let's take a look. And we got it. Nice. So these are both correct. I mean, I've done this, I think I've done this like 3 times, like these problems 3 times, but you know, there's been like a long gap in between, so. Oh, I think I see one problem I did wrong. I think I did the wrong thing. Yeah, I think I did the wrong coordinates. Yep, I always manage to get one problem wrong from this. Let's see. So 35 south of west. Is that what they said in the problem? South of west. Oh, okay. Well, I didn't get the problem wrong. It's just that I did it from the wrong direction. So I have to remember that when they say south of west, I guess I just went the... Yeah, I usually get those things mixed up. So south of west is not here. So I have to remember that south of west is not here. It's this direction. Like, I mean, at least I got the problem right, though. But at the same time, it's like, I didn't do it the proper way, though. I guess we'll just consider it, like, half credit, I guess. Half credit, I guess. I got the answer right. It's just that I attacked it the wrong direction. In the wrong angle. Let's see. Probably BM. Let's see. What do we get for B? Okay. So 6.32 miles. So let's see if that's the same as my answer, because I simplified mine. So yep, it's the same. Okay. So we got this one correct. So this one's correct. So probably like this one would probably get a half point because I actually attacked it in the wrong direction. But I did get it right though. But I'll give myself a half a point for that because, you know, like if I did it the wrong way, then suddenly I might get the wrong answer. At least I got the right answer for that, but then again, would it matter though? If anyone in the chat can like give me a reply on that one, like be sure you're more than free to do so. Okay, so problem 4.1. Okay, so I have to remember, so if it says like south of west, it actually literally means south of west. Like from west, go down south a little bit. I gotta remember that. Oh, it's getting dark in the office. I just had to turn on the light. Because I live on the East Coast and it's the sun was starting to set. Okay, so for 4.1.4, for A, negative I hat and negative J hat. Yep, that's correct. So this is correct. Oops. Check. 45 degrees. Yep, I think that is correct. Because, like, we got negative... Yeah, they basically turned it into decimals, but I'm pretty sure that's square root of 2 over 2. A square root of 2 over 2. Yeah, I said that correctly. Okay. Okay, next one. Yep, the numbers are correct for that one. Yep, they did 3 significant figures instead of 2. But so far so good. So far so good. Cylindrical coordinates, problem number 5. Full solutions for A. Okay, this one's correct. This one's correct. For B, did we get B right? Let me check, because that says like 3 point. I want to make sure that I didn't miss. Square root of 13. Oh, okay. Yeah, that's correct. Square root of 13. Okay. Because I've never seen the square root of 13, like, I guess, in its decimal form. And to me, I thought 3 was kind of small. And I was like, wait, did I do something wrong? But I got it right. So, yeah. So this is right. So this is correct. Bring this down here. Okay, 1.6. Okay, for A, let's take a look. Let's see. Our points in the I direction. Yep, we got that. So on to full solution B. Let's see what we get. It's pointing in the negative X direction. Yes, that is right. Negative I. Cool. So these two are correct. Oh. It's like, come on, pen. Work with me, please. Okay. Next. Drag this up. Drag this up. Okay, so now we are on 1.7, right? Yeah, 1.7. So solution A, let's take a look. Right, we got that correct. Nice. And for B, B. 19. Yes, perfect. Got that correct. Okay. Okay, now we're going to 1.8. Well, I mean, we're doing the spherical coordinates, and I had to look these up, so... So let's take a look here. Full solution for A. Right, yep, we got that. So this is correct. And for B, yep, we got those correct too. So yeah, because it's like R is J, and then like phi hat is like negative I. Yep, that's correct. Okay, cool. We got that one correct. So drag this up here. So this one is correct. Okay, so let's see for this one, full solution. Yep, we got that one correct. Because I remember in the past, I would always get this one wrong because I would forget the R is actually like you can convert that. Like you convert the R into XY coordinates. I would forget that part. All right, so the last one, I think this one this one is, we can get this one correct. Okay, so they turned it all in decimal form, so hopefully we did the right operations. Okay, over 38. Yeah, that looks about correct. Yep, that looks about correct. Yeah, that looks about correct. Then 1 over square root of 10. Yep, that's about right. And then 3 over, oh, nope. 3 over the square root of 10. Okay, yep, that's correct. 21. Right, yep, that looks right. 1 over the square root of 21. Right, yep, looking good. 4 over the square root of 21. Okay, yep, we got every one of these right. Awesome. Awesome sauce. So every one of these is correct. Nice. Okay, cool. Cool. We managed to get all the, well, like I still have to remember that like for coordinates, I have to remember that, you know, when they say west of south, they literally mean go west and then go south. I have to remember that. And also, like, I have to remember the coordinates for spherical. So we still have some extra time, so I have to figure, so I guess I have to like train my mind to like think about like how to think about these coordinates. So I think we can go back into our notes and like look over how to interpret it, because I think if I look at the graph, it will probably help me. It'll help me like remember it better. So spherical coordinates, here we go. And also, I would always forget these parameters. Like basically, like R can be like, you know, 0 from 0 and then to infinity, while like theta has to be from pi to negative pi to pi, and like phi has to be from 0 to pi. So yeah, so okay. So I have to remember those parameters. In addition, let's see. So R is easy to memorize because like it's practically like distance. So for theta, we have to remember it's arc cosine, and then z over r. Yeah, so we have to remember it's z over r, not like that way we don't have to memorize like, you know, that part. And then x over y, arctan. So I think like theta is going to be a little bit harder for us to like remember, but at the same time, like we reduce like the bottom part to r instead of like, you know, the square root of x squared plus y squared equals z squared. It's just the unit vectors are going to be a little bit cumbersome to remember. Well, actually, let's just test ourselves then. So I'm gonna drag, and I'm gonna try to practice. So like, because we just saw it, so let's just, I'm just gonna take a little bit of time to like try to forget it, and then let's see. I mean, I probably will still remember because it hasn't like, it's still part of my short-term memory. So, all right, so let's try, actually let's just mix it around. So let's try getting the coordinates for z and y. Okay, so r, so now I have to remember that these are r, like I remember there's an r in front, so I think this is cosine of theta, or no, not phi, or phi, I should say. Like I keep like mispronouncing it. And I think these are sines, so sine of theta and sine of phi. And I think this one, oh no, I think this one is supposed to be theta. This one's supposed to be theta, and I think like I think this is going to be theta of sine, and then cosine of phi here. Yeah, that's a good way to challenge myself, because that way I don't like memorize of what I saw. And for r is easy, so we can just write that. Okay, and then for theta, we just have to remember it's arc cosine of z over r, and then for phi, it's arc tan y. Oh no, not z. Why am I writing z here? Okay. All right. Now the unit vectors. So r hat is equal to, now the hard part. Write this. So we know this one is sine of phi, negative sine of phi, plus cosine of phi. Okay, so now I gotta actually remember the other stuff. Because I think the last term here is cosine and sine. Now, is it phi or is it theta? Maybe this will help me a little bit. So, because I don't want to make it too small. Okay, so cosine. Oh no. Oops, not j hat. I hat. And I think the next term is supposed to be sine and sine. I think, because I think it's supposed to emulate the actual coordinates. Should probably put like parentheses around these. And then like that. And then plus cosine of theta. Okay, so if it's that, like, that's just supposition for me. Because I feel like that's what it's supposed to be, if it's like R. Now, if it's... So... I'm going to take a guess, and I think it's going to be the reverse. Oh, no. I think these signs are going to remain the same. And then cosine of then sine of phi here. Then I think it's a minus sine of theta k hat. Oh, hello, Mix the Pick. Hopefully I pronounced your name right. How's it going? We have some quaternions. I wish. I don't think I know that much about quaternions. I'm just doing vectors right now. Like, we're doing spherical coordinates. I'm trying my best to memorize the coordinates. Okay, and then unit vectors. So, what's the best part of your day so far? Mix the Pick. So JK is just units? Yeah, it's just units. Okay, did we get it right? Let's take a look. Okay. I think we got it. I think we memorized it. So, well, I shouldn't say that because I have to actually just write this over and over. So, you're right. Okay, so we got the unit vectors right. Okay, so did we get the coordinates, the coordinate conversions right? So let's see. Let's look at sine. Yeah, I think we got them all right. Yay, we memorized them. Let's see. Going for a walk just before. Oh, nice. Did you enjoy your walk? I to the square is undefined, not J. Or I guess you could say A times. It was a good walk. Okay, cool. Okay, so we managed to finish all the questions in chapter 1, and we managed to test out our memory for a short amount of time for spherical coordinates. I think that's a really good achievement for this stream. We actually studied a lot longer than I thought. We actually studied for a full 3 hours. Yes. I hear the bell. Okay, guys. That was a pretty good session, actually. We managed to do 10 vector problems, and we managed to test ourselves with spherical coordinates. Not bad at all. I actually am quite proud of that. Of course, I've done these questions before, but it's been a long time since I've done these questions. So, oh yes, you're more than happy to join the Discord. Mix the Pick. Oh, and thank you for the follow. I really appreciate it. It's always great to actually see, like, whenever I'm off stream and like you guys just give me a follow, I get so happy because I'm like, wow, like, you know, like I've only had this channel up for like 2 weeks and I'm already meeting so many people that love math. But thank you for the follow, I appreciate it. And also, like, let me know if the Discord link works, just to be sure, because I want to make sure it works, because I think like with Discord their links have been like breaking a lot lately. Or maybe I've been putting in the wrong link that expires too soon. You're there? Cool, cool, cool. So I'm glad that all of you guys are in the server. Like, you know, that's a place where you can just chill, and if you have an inspiration for, like, you know, an idea in math or physics or anything in general, you can just basically post it there. If you have any art that you would like to show off, you can show it off in our art section. You know, like anything. Like, basically, I want my server to be like a Renaissance. Like, basically, what's it like in the Renaissance era, where everyone just showed off their knowledge and basically showed how much they can create. If you want to type up your own story and you want to post it in the writing section, you're more than happy to do so. And I'll be happy to, like, read it and see what you guys have developed in, like, you know, in literature or whatever. Whatever it is you like to do. But yeah, like, so we have managed to get through that. So the next chapter... we would have to do is vector operations. So I think in this chapter we're probably going to cover things like the dot product and the cross product, and then like things like the gradient, the divergence, curl, the Laplacian. Yeah, so we'll be covering those. So we'll be covering like mostly the stuff you would cover in Calc 3. So I'm pretty excited for that, because the thing of it is that I haven't covered those in a long time. So I'm kind of glad to actually get back into it. So maybe with me streaming it to you guys, I'll be able to memorize it a lot much more efficiently. So, you know, like, I think I'll probably remember the spherical coordinates a lot better since I'm actually streaming it to you guys. But maybe like every stream I probably will like start off by saying, like, probably just writing like, okay, did you remember the spherical coordinates? And I just write it down. Probably that's like a good way for me to actually train my long-term memory for that. Okay. But yeah, this was a very productive stream, guys. So I will also be streaming on my my Uncle Talks channel, which is my original Twitch channel. So if you would like to follow me there as well, you can give me a follow there as well. It's basically just like my gaming channel. So I basically game there, play a lot of gacha games there. So like if you like anime as well as gacha games, be sure to tune in if you would like to, if that's your thing. But thank you guys so much. Of course, like, even though like the time is basically say like 11 minutes at break time, I think I'm going to end stream here. So if you guys want to follow, me on YouTube, or subscribe to my YouTube channel, you're more than happy to do so. I always repost my VODs there, so if you missed anything or like you had to go like while the stream was going on, you're more than happy to like catch up with me on YouTube there. And if I did anything wrong, or if you have any tips on math or anything, you can leave me a comment on YouTube if you notice anything that I could have done a lot more efficiently, because I know all of you guys are just bright, awesome individuals, so you probably thought of like clever ways to bypass the, I guess, the rigmarole of like, you know, doing tedious things within mathematics. But yeah, I think that will do it for today. Let me see if there's anyone doing any math content. Maybe we can raid them. Let's see who's up. Oh, let's see. Oh, nobody math related is streaming. That's unfortunate. But I think we'll raid someone next time if they're doing math. But yeah, so if you want to follow me on my Uncle Talks channel, you're more than happy to do so. If you want to subscribe to my YouTube channel, please do. It's a good way to keep in contact with me, or like update my study routine if you think I can do something a lot more efficiently. And also join our Discord server. Just caught the last shoes. Hey, Unstunky. How's it going? But it looks like you got some work done. Yeah, so basically we finished like 10 vector problems, and I managed to try to memorize spherical coordinates from both the Cartesian, to transform it into Cartesian coordinates and to transform it back into spherical coordinates. So, and also I managed to remember the unit vectors for spherical coordinates. So, yeah, so basically everyone saw it on stream if you guys are still in the chat. But yeah, everyone's my witness, so probably like every stream I'll probably try to practice remembering the spherical coordinates. So probably like before I start the study sessions, I'll write the spherical coordinates so I remember them better. But yeah, so I think I said what I need to say. Like, you know, you can, like I said, subscribe to me on YouTube. You can also follow this channel if you like math or physics, or both, or you can also follow me on my Uncle Talks channel, which is also in the chat. And the final thing I will say to you guys is always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys tomorrow for tomorrow's stream. So take care, guys. Bye-bye.